Hello, my name is Kevin Stewart and I work at LI-COR Biosciences, and today we will be testing the continuity of a cable. And the tools you will need are a vise to hold the cable ends secure, and a multimeter, and some test cables. A continuity test is a simple check to see if a circuit is complete. When testing a cable for continuity, we will be looking for a visual indicator of very low electrical resistance. Some multimeters have a function that provides an audible beep when the circuit is continuous, while others will have a visual reading on the display. To begin, insert the black test lead plug into the COM connector on the multimeter and insert the red test lead plug into the V omega connector. For the Fluke 77 multimeter, turn the selector knob to measure resistance labeled omega. The Fluke 77 multimeter has the auto range feature. Therefore, it will not be necessary to select a resistance range. Some multimeters have several values in the omega selection area. For the Gardner-Bender multimeter, turn the selector knob to the omega area with multiple values to select from. You will want to choose the lowest value. 200 ohms is typical for many multimeters. When continuity is detected, you will see a visual indicator on the multimeter of very low resistance. When continuity is not detected, you will see a visual indicator similar to the following. The number 1, as in the Gardner-Bender meter, with a decimal point, a number 1 with a decimal point, or OL, as in the Fluke 77, which stands for open loop. In this example, when we touch the probes, they complete the circuit and a very low resistance measurement is displayed. If the multimeter is set to audible, a beep will be heard. Now when the probes are separated, they do not complete the circuit and a high resistance measurement is displayed. Now we are ready to measure continuity. The cable we will test has multiple stranded wires. Each wire must be checked for continuity. Place both ends of your cable in a device to prevent movement and align the key on each connector to the 12 o'clock position. As an example on the diagram, each key is mounted and located at the 12 o'clock position. Touch your test probe to your selected pin on one end of the cable. Then, with the other test probe, touch the corresponding pin at the other end of the cable. If you have continuity throughout the wire, the multimeter will display a very low resistance. If a wire is broken within the cable, or one of the individual stranded wires has multiple broken wires, the multimeter will indicate a high resistance or indicate an open loop or incomplete circuit in that wire. Perform this test on each pin until each wire has been checked for continuity. If high resistance is confirmed on one or more wires, disassemble the connector assembly if possible and repair the broken wire. If it cannot be disassembled and repaired, replace the cable. An additional continuity test for the cables is to have a person flex the end of the cable as you are checking continuity on your selected wire. Bending, twisting will incorporate or cause an intermittent connection if that is the case. And that is the basic overview for testing the continuity of a cable. If you have any further questions, please feel free to contact LI-COR Biosciences.